Okay, we're going to look now at dividing complex numbers. So just remember, when we did this with surds, we multiplied the top and the bottom by the conjugate of the denominator. So that is to multiply the top and the bottom by 5 plus root 4. All we've done is change the sign to get the conjugate. In doing this, we're making the denominator equal to 5 times 5 minus 5 times root 4 plus 5 times root 4 minus root 4 squared, which gives you just a whole number, 21. So we got rid of the surd term by multiplying by the conjugate. When we're dealing with division of complex numbers, we're going to do the same thing, except we're going to use the complex conjugate, which is exactly the same, except we've got an imaginary part and a real part to our denominator. So here we've got 2 minus I over 1 minus 2i. So we're going to multiply by the complex conjugate of the denominator, which is the same thing except we change it to a plus sign instead of a minus sign. Multiply and divide means we're not actually changing the equation, because 1 plus 2i over 1 plus 2i is just 1. Right, I'll expand out the numerators first. So 2 times 1 is 2. 2 times 2i is 4i. Minus I times 1 is minus I. And minus I times 2i is minus 2i squared. And for the denominator, it's going to be 1 plus 2i minus 2i minus 4i squared. Now I'm just going to simplify the top first. 4i minus I is 3i. And we're going to have this minus 2 times negative 1, because if you remember, I squared is minus 1. This will apply to the bottom. And because we use the conjugate, we're only going to have real numbers on the bottom. So it's going to be 1 minus 4 times negative 1. So our complex conjugate has allowed us to have a whole real number on the bottom. It doesn't have to be whole, but it'll be a real number. This can be written as 4 over 5 plus 3 over 5i, and here we've written it as just the real part plus just the imaginary part. And as a decimal, it looks like that. So a divided by b, if there are two complex numbers, would give you this, just in the form x plus iy.